This video will go over the Check Your Understanding from 5.3b, Tree Diagrams, Probability. A computer company makes desktop, laptop, and tablet computers at factories in 2 states, California and Texas. The California factory produces 40% of the company's computers, and the Texas factory makes the rest. Of the computers made in California, 25% are desktops, 30% are laptops, and the rest are tablets. Of those made in Texas, 10% desktops, 20% laptops, rest are tablets. All computers are first shipped to a distribution center in Missouri before being sent out to stores. Suppose we select a computer at random from the distribution center and observe where it was made and whether it is a desktop, laptop, or tablet. So first we're going to construct a tree diagram to model this chance process. And you're going to want to do that whenever you have kind of multiple events that are conditional on each other. We have different probabilities of it being the type of computer based on where it is formed. So your first thing is it made in California or Texas? And then branching off from that are the 3 different types of computers. So you start off with this idea of all computers, a 40% chance that a computer at random is from California, and then this is the probability it's from Texas. Now, given it's from California, so this 0.25 is the probability that it's a desktop given it's from California, a laptop given it's from California, and a tablet given it's from California. Same thing with Texas. Now, these probabilities here, this is the probability it's from California and it's a desktop. You multiply 0.40 times 0.25 to get that 0.1. You multiply down the tree. All of these probabilities, what do they sum to? And if you did it right, is there a 1 here? Nope, but it should be 1. They will all add up to 1. That's how you know you constructed an accurate tree diagram. Okay, so we have our model. Find the probability that a computer is a tablet. So let's just look at our branches. So that would be if I went down this path and got the 0.42, or the California path tablet, 0.18. So the probability that something's a tablet is equal to the probability it's from California and a tablet, or if it's from Texas and a tablet. So you can add up, right? Or means add 0.18 and 0.42. So the probability it's a tablet is the probability it's a tablet and from California, or a tablet and from Texas. Add those 2 up. So a 60% chance if you choose a compute device at random that it's a tablet, because it could be from either Texas or California. If we select 4 computers at random from the distribution center with replacement, so that with replacement is important because it means these are independent events. Knowing the outcome of one isn't going to affect the other, because if I took one out, there would be 1 less computer in the mix, so it might affect the final probability. What is the probability that at least one of the computers is a tablet? So that's tough, at least one, because 1 could be a tablet, 2 could be a tablet, 3 could be a tablet, or all 4 could be tablets. So instead of finding those 4 different probabilities and adding them up, something easier to do is 1 minus the probability that none of them are tablets. That's much easier. And actually, we have the probability that it would be a tablet. So let's find the probability that none of them are tablets. So this is 1 minus the probability of the complement to being a tablet, not being a tablet, which if the probability of being a tablet is 0.6, the probability of it not being a tablet, 1 minus 0.6 is 0.4. So 1 minus, and then all 4, these are independent events, so you can just multiply them. So 1 minus 0.4 to the 4th power, or a 97.4% chance. Given that a tablet computer is selected, what is the probability that it was made in California? So given we know it's a tablet, what's the probability it was made in California? So of that 60%, what percent were from California? Kind of thing. For one like this, I kind of like to set up the formula. So that's here, probability, it's from California, given it's a tablet. So that's the probability it's from California and a tablet out of everybody or all of the probability that's a tablet. So that 0.6 is the denominator, and probability it's from California and a tablet. So from California, zero point 0.4 times 0.45, that's that 0.18. So 0.18 out of 0.60, or 30%. So you can think of this kind of conceptually because you're restricting to just the tablets and then what percent of those are from California. You could think of the formula, and you get 30%. So those are some tough problems. So hopefully you reviewed that and that this helped.